All right, let's talk about scalar multiplication. So let me just preface this thing with here's u. It's a vector. Where's it based?
Origin.
Well, you haven't put anything.
I haven't put any arrows, right? But I also haven't said that it's based anywhere.
Okay, so you assume that's
So
zero.
probably 0, right? Okay. So we could throw in some origin axes here. I'm not going to be so concerned about this for this part, because really what I want to do is ask, if I wrote down u plus u, it seems like
Coming to you.
it should probably be 2u, right? Okay, so let's just define scalar multiplication so that happens. Cool? What does that mean in terms of this vector u? Well, if I start with a u, right? How do I add u to u?
Stick another one on.
You just stick it
Yeah,
on the end.
take another one and stick it on the end. Okay, so this whole vector, right?
It's 2, 3.
That guy's 2u. And in terms of an arrow, how is that related to u? Seems like it's really damn close, right? It's like pretty much the same thing as u, except,
Which is
Twice
twice.
the magnitude.
yeah. So it's same direction as u, but
Twice the magnitude.
twice as long. Okay, so that begs the question, is there a natural way to say what 1/2 u should mean? Yeah, it seems like this should be u's direction, but half length, right? So if I was going to draw that, this shouldn't be a stretch, right? You draw u, but only half as long.
Instead of a stretch, is a recoil.
Yeah, so this is really all we mean by scalar multiplication. Is what we're going to do is we're going to leave the direction unchanged and we're going to change the length. Cool? All right. That brings up a good question. How long is a vector? Like if you had coordinates for a vector, how would you figure out how long it was?
The distance.
Magnitude?
Yeah, it's the magnitude, right? Which, forget that.
Just measure it.
Square root of the sum.
Yeah, how would you measure it?
A ruler.
Distance formulas.
You're such an engineer. Just measure it, dummy. Get a ruler. How would you measure it with math? Yeah, use the Pythagorean theorem on it, right? Use the distance formula to figure out how far the end is from the 0, 0. Right? If you had coordinates, that would be as easy as squaring all the coordinates and then square rooting their sum, right? So there's a symbol for this. It gets from linear algebra.
Yeah.
What is it?
Isn't it double bracket? Well, not the double.
It's like double absolute.
Yeah, double absolute value.
Yeah,
Bar.
Or
Yeah.
yeah.
kind of double absolute values.
It's the length of the
And
vector.
yeah, this is the, I'm gonna kind of say a lot of different words for this because I have a lot of different words for this.
Isn't there like a unit vector set?
Yeah, we're not doing that yet. We'll get there later. So for right now, I'm gonna say the length of a vector b, or the magnitude, or I might occasionally say this word norm.
Yeah, that was such a hard.
Yeah, and really all I mean is the square sum of the coordinates, right? So if you want to calculate this, this is just the square root of x squared plus however many coordinates you need. right? So if you use a two-dimensional vector, you need the square root of x squared plus y squared. If you use a 17-dimensional vector, you need 17 terms.
17 is a popular number for examples.
Yeah.
There's good reason for that.
Why?
Mathematicians have a thing about picking prime numbers for some reason. 17 is kind of big, but I also know it's prime. So.
Big but not too big.
All right, other questions on this? Well, how would you do this if you actually had coordinates? Like, how would I make u half as long?
Half all
You'd have to have half
Components.
of x
Divide
and y.
each one by
Yeah, multiply each coordinate through. So,
Do one
Let me
half the square root.
kill this and we'll start it.